Welcome back to my channel Swetha CVENV. Do like, share and subscribe my channel among your friends, and you can also follow me on Instagram ID at the rate I'm Shwetashway. Do hit on to the bell icon for further notifications. So my dear friends, we were discussing regarding air pollution monitoring and control subject, done by me. So we are going to discuss in terms of sixth chapter. It is analysis of air sampling, and by this we are going to conclude our subject air pollution monitoring and control. So we'll discuss with the sixth chapter. In terms of contents, if you consider, we are going to have the three contents, that is factors which are responsible for accurate data analysis, and what are the chemical methods in terms of gravimetric and volumetric methods, in case of instrumental methods like spectrophotometry and thermal conductivity methods. So we are going to discuss in a conceptual ways. So basically you just note on these points here. 8 points are there. The major factors which are responsible for calculating or for analyzing the sample to get an accurate result or to get an accurate data. So what are these 8 points? One is the statistical studies. Second one is size of the samples. Third, changes in the sample during and after sampling. Then fourth is continuous and intermittent sampling. Fifth, sampling of volatile constituents. Sampling of particulates. Sixth point. Seventh is sampling of waste gas. And the last is sampling in open air. Okay, so we'll discuss what exactly statistical studies give us. So exactly it gives us the basic data in terms of whether the size or the frequency of the sampling, what are its like basic indications and all. So we get to know by statistical studies. It just gives us a probability, or it just gives us an average value where it may relate, or we can say that, or it may just get connected to the actual results in certain limits. So within some points it may vary. We don't get the accurate results, but we get the probable results, we say. Okay, according to the statistical studies. In terms of size of the samples, here we should always consider the large samples. When you're going to consider for sampling and all, the sizes of the sample should be in a large amount, or we can consider whatever the samples you're going to collect should be large, and should be large in number, so that the analysis will be in a good manner. Okay, so sizes of the sample depending upon the sizes, whether it is a very minute one or the bigger one, pollutants, etc. So depending on, but here only the concentrate is the sample what you're going to collect should be in large number. If you are going to collect 5 for today, then while analyzing, some 3-4 will be wasted off, and last only one sample will be remaining, and even in that also if you don't get the result, then it will be a dissatisfying thing, dissatisfying thing, you can say. So what you have to do is you need to collect max number of samples, like 10 to 20. Thereby you can go for analyzing with the advanced technologies, we can say. So in terms of, if you consider changes in the sample during and after sampling, so this thing where usually an investigator or a laboratorian fail, or he makes a mistake, so he forgets off, or he does the mistake every time. So he has to be very careful during this time. Why? Because he has to mentally feed in his mind that what or how the particular sample was in prior to sampling analysis, and after that what it has got into. So he has to feed these results. In case of continuous and intermittent sampling, here an automatic continuous recording apparatus or an instrument will be used for calculating the sample. Okay, in case of intermittent sampling, they used to use in prior, but nowadays the continuous recording apparatus is more widely used. Why? Because it gives at spot the results, so they are going to use it more. In case of sampling of volatile constituents, here also they say that they make much errors or mistakes. Why? Because whenever you're going out to collect the sample, the volume of the air should be more or in large amount, so that whatever your sample you're going to collect it, you will get in a good way the results. Okay, in case of sampling of particulates, what is going to happen? In case of here also, during the collection of particulates and all, even here you're going to make some kind of errors. Why? Because here what is going to happen, whenever you are going for sampling, so it has to be considered, or it should be collected in an isokinetic condition. What is this isokinetic condition? So they say that isokinetic condition is the velocity of the particles and the gases which are entering into the probe nozzle should be equal to the velocity of the gas which is liberated out. So to the input to output, it should be equal, the speed, or we say the velocity, right? So if that is the condition, then your mistake will be invalid, means you will not make a mistake in terms of collecting these samples. Okay, and along with that, they say that during the sampling of particulate matters, what is going to happen, the mistakes will be done because of agglomeration. Agglomeration is nothing but they start accumulating at some space, and that will in turn be a big mess. So along with that, due to which even the particulate matter will get break down and they create a mess. So these are the errors what we find in terms of sampling of particulates. Along with that, they also say that the gas stream which is going to be sampled, right, So its surface means where that particular apparatus is going to be placed, which is going to calculate or analyze the pollutants quantity or concentration and all. That particular surface should be near to the gas stream, so that the pollutants will be directly attached or collected directly onto the surface. If not, again they are going to deposit on those collecting units, and they condense and they form again a barrier in analyzing the things. Along with that, they also say that yeah, it should not, that's what, even the gas stream has to be in same speed and same direction. It should not go in opposite way. If it goes in opposite way, then everything will be disturbed. Okay friends, so these were the conditions for sampling of particulates. One, we got to know in isokinetic conditions where input is equals to the output, same speed and same direction. The other thing is surface should be very nearer, so that for analyzing or for collecting the particulates will be easier. In case of sampling of waste gases, here also they say that they find it difficult in analyzing. Why? Because here the temperatures will be very high, due to which the gases will get disturbed, their speed may vary, and thereby the analysis may get disturbed. So it may vary. So what they do, at certain points sample collection units will be placed, where they take from each unit, or they collect each unit sample, and at last they do the average analysis, and then they get an accurate value. Okay, so in case of sampling in the open air, what they're going to do here, they also say that even it is also quite difficult. Why? Because some of the pollutants, as I said in previous chapters as well, that some of the pollutants will get dispersed in the air, right? So it becomes very difficult to collect them. And also they say that it's a needy thing, that we need to uh, collect the sample in large number. So this is a basic thing, that whenever you're going for any kind of analysis, you need to collect max number of samples, so that you should not come back again saying that I have what we can say, like I have insufficiency of the samples and all for testing purposes. So at a time, at a stretch, you have to get some 20 to 30 samples, so that you can do analysis in a good manner. Along with that, it's very difficult also to maintain isokinetic condition during the sampling analysis if we are outskirts and all, depending on the pollution or in terms of whatever external factors, it will vary. For example, wind speed or the directions and all, it will vary. Meteorological things, if it's raining and all, then again it gets disturbed. So like this, depending on that also, they are going to affect the accuracy of data. Okay, so these were the conceptual analysis or explanation regarding factors which are affecting the accurate data. So we are going to discuss regarding the chemical methods. In that, we are having gravimetric method. So just look at the drawing. I will just explain the things. This method only aims in weighing the substance either directly or indirectly by forming a compound. Okay, in that particular compound, it is going to weigh the quantity of the substance present in it. So it is going to determine only those. If say for example A plus B equals to C, so in case of C compound, again it gets divided in maximum conditions like C1, C2, C3, and thereby what will happen, they start calculating how much amount of C1 is present, how much amount of C2 is present. So like that they don't calculate. So A and B are the pollutants, so they are forming one compound C, and it's divided. So you got my point. So like that, so you can see here in the gravimetric method, solid soluble salt containing lead and other chemical species, they are going to add in one sample. Okay, and they are going to dissolve it with some of the water. Okay, later on they're going to add the sulfur oxide to it, and then what is going to happen, the lead sulfur oxide is going to be formed, and thereby the other gas will be liberated out, and whatever the remains are there, it will be taken out for analyzing with the help of a filter paper. Okay, so that filter paper will be weighed to know the quantity or the percentage of the pollutants present on that particular surface of that particular paper. Okay, so this gravimetric method, they consider it as a simple analytical technique. Okay, it is also used in finding the gas sensitivity, along with that in finding dust and soot which are collected in the sedimentation jar, as well as it is also helpful in finding the particulate matter which are dispersed in air. Okay, so that's whatever the sample is collected on the filter paper, they are going to weigh directly. Okay, either with the help of impinger or electrostatic precipitator, whatever sample they are going to collected, so it will be again weighed back by using gravimetric method. So this was about gravimetric method. They are going to weigh the pollutants. Okay, so by making one compound and again dividing that particular compound in many divisions, and thereby they collect it, or they are going to calculate the last result or the end result. In case of volumetric methods, we always know, we have done even PUCs also, these kind of volumetric analysis, so we will be having an idea if you just look into the drawings. Sorry for my disturbing voices. Okay, so in case of volumetric analysis, what is going to happen here? The components are not weighed, whereas they are determined by means of reagents of known concentration. By knowing the concentrations of a reagent you are going to use, you are going to calculate the pollutant concentrations. Okay, so in that we are going to have in three divisions how volumetric analysis will be done. That is acidimetric and alkalimetric method. Okay, then oxidation and reduction method, then is precipitation method. So these are the three methods what we consider. In case of acidic and alkalimetric methods, if we consider, so we always know that in case of finding acid or a base in that particular solution, we add up. If it is acidic, we add base as a solution. If it is base, then we add acid as a solution. Along with that, at the end result, we add an indicator so that the color change will result us what is that particular solution or what concentration it is present. Okay, we used to do these things, we use it. So we have that idea regarding acidity or alkalinity test we usually do, right, in our chemistry lab. So like that, the acidimetric and alkalimetric method includes in it. Okay, so they say that it is a very sensitive method, 0.01 ppm sensitivity. Okay, even a 0.1% of the ml also, if it is added into that solution from the titrant or the from burette, okay, everything will be like all that whatever you are sampling analysis you are doing, it will be like spoiled off. Again you have to start, again you have to restart it. So like this the conditions will happen. So you have to be very cautious while you are doing this kind of titration or volumetric analysis. Okay, in case of second is the oxidation and reduction method. Here, in case of oxidation or reduction method of any kind of sample, if you are analyzing here, they are going to supply a quantity of oxygen which you are going to know. Okay, a measured quantity of oxygen you are going to supply to know the concentration of the pollutants or the quantity of the pollution present in that particular sample pollutants. Okay, so here either you add the indicator or you don't, because at the end result, for some they directly show the end result by color change, or for some they add the indicator. So here it is not mandatory that you need to add indicator, whereas in case of acidity and alkalinity test, you need to add indicator. In case of precipitation method, this drawing resembles, that is, here it is suitable for halogens where the silver nitrate solution of known strength which precipitates the halogens in the form of silver halide, and this is not a very sensitive method. They say it is not case sensitive, we say. Okay, so it is suitable for halogens. Here silver nitrate solution is added, you can say, for the water sample. So how they are going to do the sinter glass filter precipitate, here they're shaking, again the precipitates are obtained, then again it is sent for vacuum palm filtrates and all. So to get at last the pollutants, then they're going to measure it. So you can also see in case of some other usual manner of volumetric analysis, the sample is going to be weighed parallelly analyzing. So then they're going to add this particular solute in small amount of solvent. Okay, then they're going to use stirring rod, then it is transferred to some standard flask, then stopper and shake. We close the lid, which is termed to be stopper, and then we are going to shake vigorously so that the reaction will be vigorous. Then carefully they make up to the mask on the flask. That is nothing but they are going to fill up the distilled water till the mark what they have given. So again they are close it off, and then again they're going to shake. Okay, then it is again rinse all the solution into the flask with more solvent. So again they're going to add the solvent if it is necessary, distilled water is used. Okay, distilled water plays an important role in any kind of analysis. Okay, it just clears as well as acts as an additive type, right? So people have these ideas regarding volumetric analysis in your PUCs, so you can get to know. Even in case of spectrophotometry also, we have studied even in engineering first year, we had in physics lab about these things. So in case of spectrophotometry, it is also termed to be absorption spectrophotometric method, or we can call absorption spectrometric method, which is in single state, we call it as spectrophotometry. Okay, so its principle is on absorption of the certain range of electromagnetic radiations in the visible, ultraviolet and infrared regions of the spectrum. So what is going to do, so it is going to absorb the radiations passed through it. I mean, it has a UV and infrared region where these radiations will be passed, and how much it is going to be absorbed, that will be analyzed further. So it is one of the most important of all the instrumental methods of analysis, they say, and the absorption varies with the wavelength of the incident radiation. The measurement should be carried out either with a monochromatic light or with light having a limited spectrum. If the light is having a minimum spectrum, then even by that we can use for analyzing the things, and it also depends upon the wavelength of that particular incident radiation. Okay, so whether the solution is like having more pollutants and all, it is going to calculate zinc, sulfate, lead, etc. Okay, the wavelength of the beam emerging from the source of the radiation is suitably adjusted in this way, and then it is passed through a layer of substances to be examined. So first that UV region, it will be focused. After that it will spread its wavelengths towards the solution where it has to be examined. Okay, in the visible region of the spectrum, the concentration of the colored substance analyzed by this method can be derived from Lambert-Beer law. So we have studied even in case of PUCs also this way. According to the law, the light absorption is proportional to the concentration when the layers analyzed are equal to thickness. Further, this method can also be applied to the analysis of colorless substances by studying absorption in the UV region of the spectrum. So I will just say you, so this is the basic principle of the spectrophotometry. Now I'm going to say you how exactly a particle spectrophotometer instrument is going to work. Here you are going to consider the distilled water. It comes in a box, okay? This particular spectrophotometer, it will be having this light source, the collimator, which is nothing but the lens, and a monochromatic thing, wavelength, series, and all will be there. Your task is to have the sample, means you will be given in that particular instrument a space where you can keep this particular sample in a small, like mini, what we can call mini test tubes will be present, okay? So they will provide in that particular equipment only. So first, what you used to do, you just need to clean the outer surface of that particular test tubes, okay? And then what you're going to do, you're going to add the distilled water, you're going to place it, then you're going to start it. When you start the spectrophotometer machine, then it gives some value called as something 0, okay? Then it is ready for the work. Then you need to take slowly that particular distilled sample test mini test tube solution, and then you have to take another mini test tube where it will be having the sample which you want to calculate. So you're going to add that, then you're going to place it in the same place where you had spread in the distilled water. Hence you have replacing its position by distilled water to a sample solution. Then again you have to start the thing. Then the reactions are going to enter like this: light source to the lens, then monochromatic prism sends the wavelength, then the sample is analyzed, then the detection analyzes the waves, and then it shows in the digital display meter, okay? Here it gives a value stating that it has this much kind of lead, or it has this much amount of zinc, or any kind of other pollutants if you're having particulate matters or any kind of volatile matters, etc, etc. So any kind of pollutants it may be, it will detect, okay? It will detect and it will display like this. So you are going to note it down, okay? So direct instruments methods will give you direct analysis regarding the pollutants. So this is how it is going to work. So let's start up with the last concept. In case of instrumental method, we are having thermal conductivity method. In case of this, what is going to happen, even it has a principle, that is, it measures the thermal conductivity of the gases and vapors. Here the limited, since the method is having a limited usage, why? Because it cannot identify the gas, but it only calculates the concentrations of the substance which are present in it, okay? So the overall, what they're going to say, that the overall index of thermal conductivity gives us that only it can be applied to those cases where the conductivity can be measured before and after eliminating a particular constituent, so that the later can be determined from the difference. So it just gives us your prior and after the position value. After that, the average value what you get, that will be the actual result. So you just get A plus B. The C you need to find. Got it? So what is going to happen here is they say that in some of the cases, what is going to happen, whatever the thermal conductivity is there, that particular instrument or an apparatus is going to use the combustion apparatus known as explosimeter, okay? Explosimeter, here the concentration of vapor or the gas will be identified as a percentage. According to its reference, they will find the explosion limit, okay? In this method, what is going to happen, a filament is electrically heated in a special apparatus to a temperature at which the gas or the vapor becomes oxidized and burns at the surface of the filament. So at the filament, it is going to be heated where the gases and vapors will be burnt, okay? Then the energy will be developed during oxidation, nothing but the combustion, is then measured with a thermocouple. So whatever the combustion is taking, how much energy it is utilizing or how much energy is generated, that will be measured by thermocouple. This method is mostly used for determining carbon monoxide. Thermal conductivity is used for determining carbon monoxide, and along with that, they say that thermal conductivity has though less applications, okay, in terms of calculating any kind of other samplings, but it has a wide range of applications in terms of industries, because it is going to calculate the gaseous effluents, okay? We know that carbon monoxide or sulfur oxides or nitrogen oxides, everything gases are limited from the industries itself. So they are going to use this kind of thermal conductivity instruments or equipments for finding how much amount of pollutants are liberated out. So this kind of thermal conductivity, people can just see here how a picture, see, insulation box is there, then we have heat foils, temperature distribution plates are there. Here the sample is going to be analyzed. Here the snow sample they are going to analyze, okay? So like this, see, even here the two samples are there and heating lights are there, plates and insulation, power supply, similar specimens, voltmeter, then guard ring and insulation. So like this, you got an idea regarding thermal conductivity, okay? So this was the basic conceptual ideas regarding our analysis of air sampling. So we have completed successfully our air pollution monitoring and control subject with these 6 chapters according to your diploma as well as VT universities. So do refer to it, to all the engineering students, it is useful. And also I welcome all the new subscribers, and do keep supporting me like the way you are right now. And thank you and God bless you all. As I always said, please do like, share and subscribe my channel, okay? And you can also ping me on Instagram if you feel something variation or something else the topics could be for you guys, where I can explain and all. So you can also give your suggestions. I always welcome. And thank you. God bless you all.